Hello, this is the third video that we have talking about absolute value equations. There will probably be a fourth before we get into inequalities. To refresh our memory, this example here, we want to isolate the absolute value. We want to get this all by itself. To do that, we subtract 2 to both sides, and we end up with 3 times the absolute value of x minus 1. And again, all this stuff here covered in purple, we want to get by itself equals 6. This 3 is out here, so we divide by 3, both sides, and we get absolute value of x minus 1 is equal to 2. Now that the absolute value is isolated, we write this out as two equations. X minus 1 equals 2, x minus 1 equals negative 2. So we take what's inside the absolute value, the x minus 1, and it's written down here and here without absolute value signs, and it's equal to 2 or the opposite of 2. And then we solve. We finish this up by solving the equation. Now, if you notice, once we isolated the absolute value, here we just had a number. What happens if there's a variable? What happens if we have a mathematical expression? That's what we're going to look at next. So, this equation, I've already isolated the absolute value. We have the absolute value, and there's nothing else outside of that. So now we write our equation, just like we did before. Two equations. X plus 10 equals this, 4x minus 8, and x plus 10 is equal to the opposite of 4x minus 8. Notice I'm using parentheses. Minus, fix that, it's supposed to be minus 4x minus 8. We use the parentheses so we distribute that negative. What happens here is we get negative 4x and a positive 8. And we solve these two equations. The difference here, besides having to distribute this negative, is we will have to check our answers. So, minus x, and we get 10 equals 3x minus 8. We have 3x plus my x. And now we add 8 to both sides. And we have 18 equals 3x. Divide by 3, divide by 3. X turns out to be 6. Over here, I'm going to add 4x. And I end up with 5x plus 10 equals 8. Subtract 10. And I get 5x equals negative 2. Divide both sides by 5. And I have x equals negative 2 fifths. Now, we have to check our equations. So we go back to the original equation, absolute value of x plus 10 equals 4x minus 8 must be the original equation, and the absolute value of x plus 10 equals 4x minus 8. Now we put this x equals 6 in here and here, and we put x equals negative 2/5 in here and here. And we want to check and make sure they're both true. Sometimes they'll both be true, sometimes one will be true, one won't. Now, I have 4 times x, which is 6, minus 8, and on the right hand side I have the absolute value of 6 plus 10. I got the absolute value of 16 equals 24 minus 8. Absolute value of 16 is 16. 24 minus 8 is 16. 16 equals 16. It checks. This answer is good. Now I come over here. Plug in negative 2/5. Absolute value of negative 2/5 plus 10 is equal to 4 times negative 2/5 minus 8. And now I'm going to operate on the right hand side first. 4 times negative 2 is negative 8/5 minus 8. A negative minus a negative equals a negative. Absolute value, this is an absolute value here, has to equal a positive number. I don't even care what those two numbers are, because a positive is not equal to a negative. I know we have a bad answer, and we can stop. We don't even have to evaluate it in this case. But pay attention, although this is a negative here, it doesn't mean that it's going to be a bad answer. You'll find in your homework that a lot of times negative numbers are good answers, and sometimes positive numbers are bad answers. So, in this case, we find that the x equals negative 2/5 does not work. We cross it off, and we give our answer as 6. So, some of our problems today, and it only happens where the variable is outside the radical. Variable is outside the radical. It becomes necessary to check to see if we have a bad answer. Just so you know, this answer here is called an extraneous solution. I'm sure you'll hear that term later on in your math career. It's an extraneous solution. So, I hope this helps. Tomorrow's homework, we will be solving problems that look like this. Not many, but a few. Have a great night, and see you tomorrow.